Okay, good morning. Welcome to my praise for the monolith. Let's see if you can share my emotions. So that's me. I like the character. I think there's a striking resemblance with me. This is where I started to work recently. In October, I joined the organization that is building the next version of the Quixit app. Maybe some of you know it. As you can see, it's more focused on Germany today, which will change. Yeah, we are building a new backend for this system, and it's a monolith. So why do I give this talk here at the Microservices conference? Because I want to be, shouted at and abused a little bit, get some really serious questions later on maybe. So why this talk? No, it's a real story behind it. So last year in October, I went to the product camp that happened here in Berlin. Anyone know product camp? Anyone been to a product camp? Yeah, one there, okay. Very interesting event for me. It is in the format of open space, so there's no invited speakers, just open spaces. And one of them was, one of these sessions was initiated by a product manager from a startup, and she shared a little bit of her experiences with microservice architectures and wanted to get some feedback from the community. So she comes from a startup with a really well-established product, growing customer base. That's good. The whole business was based on one monolithic application. And this monolith would occasionally crash and occasionally suffer from not so desirable behavior under certain load situations. So obviously that's not good. You want to be available, of course, with your growing business. So something should be done about this, I guess. So they went out and hired a new CTO to address these problems. Okay. CTO sat down for a few months and did some hard thinking and designing, came up with a microservice architecture style that uses event sourcing even. They use Kubernetes. They had a rather small team, so I don't recall the exact number, but around about a dozen developers or so. Not all of them located in Berlin, some of them in a different time zone, but not so far away. I think it was just 1 hour ahead or so. So it sounds like you should be able to do a good development process here. Maybe 1 or 2 services in the one location, the other ones in the other. It should work, right? What could possibly go wrong? Now, the surprising story that she shared is that ever since we started with the new architecture, it's taken us much longer to get any feature out of the door. And she went on, no story fits into our 2-week sprints anymore. Now, that's obviously bad news. We don't want to hear that. So we obviously, in this situation, in this context at least, the original intent was never met. So with microservices, we heard this a lot. You want to go fast. You want to have teams that are autonomous, that can release and deploy independently from each other. And somehow it looks like this didn't work here. And the organization is facing real trouble now. That's really bad news. So they're just in this growth phase. They're having more and more customers on their platform, and now they suddenly can't develop features anymore. So what should they do, and what can we learn from it? Where's the problem? So it looks like there is yet another problem, and I think some speakers have already addressed it here, but I would like to share a few more opinions from the community at large. So this is from Martin Fowler, so it must be right. This is, well, yes, I mean, read it. It's a really one of his great blogs on his Blicky, I think he calls it. And what he says is, don't even consider microservices unless you have a system that's too complex to manage as a monolith. The majority of software systems should be built as a single monolithic application. Pay attention to good modularity, but don't try to separate it into separate services. Okay, it's Martin Fowler. In this block, he has this interesting graph as well. Actually, for me as an engineer, of course, this is an appalling graph. You can't do that. I mean, there's no scales, no units, nothing. What is base complexity? I don't know. At least he argues that when complexity increases, there comes a time where you should probably think about splitting up your architecture. So at what time that exists, or that crossing point there will be, no one knows. But honestly, yes, it resonates well with me, but I'm not so concerned about these curves so much. I find much more interesting what's there on this slide at the bottom right, which is also in Martin Fowler's blog. So he says, but remember, the skill of the team will outweigh any monolith microservice choice. I find that extremely relevant. And so I zoomed it in a little bit more, and I want to keep this in mind for the rest of this talk and for the rest of this conference. So that's interesting. Here's another one from Mary Poppins. She gave a really nice keynote last year at Go to Berlin. And at the end of that keynote, obviously there was a Q&A session. So one of the attendants asked her, what do you make of a lot of organizations today jumping on this microservices train, and maybe they don't even have to, and maybe they're not well equipped to do this. What's your view? So she says, okay, at some point you have to figure out how to migrate, yeah, okay. But if you take that company's solution, it's their solution. It's not your solution. And it took, at Amazon at least, she quotes, it took 5 or 6 years, maybe even longer. There are other examples like SoundCloud. I happen to know it. They've been working more than 4 or 5 years now to replace the monolith with whatever architecture comes after it. They're still working on this. So every one of these things took long to go from an idea to actually developed at scale. And I liked her last sentence. If you think you can do it in 5 months, you're crazy. And she got a little bit, affirmative at that moment. You're crazy. It ain't gonna happen. So that's Mary Poppins. This guy here, I think, sums it up. It's a pretty similar direction as what Mary said before. If you can't read it, I'll read it out. So this guy says, I want to adopt the Netflix infrastructure as is, but with a fraction of a percent of the engineers. Is problem? He got some really interesting replies there, obviously, and I think that really sums it up. There is obviously a big complexity involved in all of this. So what can we do? I said before that I decided to build yet another monolith, and that I like monoliths. So I guess the question is, are there any good monoliths? Do they exist? Anyone? So I think they do. That's obviously the premise that I'm making. And it would be super nice if they did, wouldn't it? Because we could postpone our migration to microservices. We could take that decision much later. We could concentrate more on business value, get customer-facing things out of the door, and deal with the complex deployment and keeping things running situation much later. That would be great, I think. So most of my career, I have worked with monolith. And it paid me, it paid a lot of other people, it made quite a few companies make money. And I get the feeling that most of the remainder of my career will be focused on monoliths again. So I have worked on some that were horrible. Of course, they were not mine. As a consultant, of course. No, but seriously, I've worked on some that were, I think, elegant, flexible, and easy to maintain and enhance. So we were pushing out new features on a regular basis. We were using continuous delivery with monolith. So, show of hands, has anyone here worked with a monolith that has been kind of good, that has these attributes? Few hands. Okay. Maybe only 10% of the audience. So that's obviously bad news, because it means 90% have worked with monoliths that were crazy or bad, or never worked with monoliths, maybe. So do they exist? That's the question. So would anyone like to guess what this is? No, not yet. ServerX. It's obviously some kind of hardware. Sorry? Power supply? Supercomputer? Maybe. So, no, I'll tell you. It's a telephone switch. It's a telephone switch made by Ericsson. I don't know when exactly, sometime in the 80s or 90s, this photo was taken. So if you make a phone call with your smartphone, there's a really good chance that it will be routed through some device like this. A really good chance that it will be an Ericsson device even. They are still very big in that market. So they've been selling and operating these things at scale for decades and making millions with it. And in fact, at some point, they decided we should even have a language that is only devoted to programming these things. So they developed a language. And I think most of you probably know this language. It's ELAM. So you can recognize I'm a bit of an ELAM fanboy. The guys you see here are the original designers back in the 80s. That's Joe Armstrong on the left, Robert Werding in the center, and Mike Williams on the right. And these snapshots are taken from Erlang the movie, which I recommend you have a look at. If you haven't seen it yet, it's on YouTube. It's actually quite funny. And I don't know whether it was ever intended to be funny. It's weird. Have a look. There's also a sequel now, Erlang the Movie Part 2, which is even crazier. So they seem to have a sense of humor, I would say. In the background, we even see some Erlang code. Yeah, it's a snippet taken from React, the database. So few facts on Erlang then. It's a functional, dynamically typed language. So if you like your Haskell, if you need a static type system, sorry, Erlang is not for you. It features immutable data structures and pattern matching, some really, really nice tools that you don't want to miss once you had the chance to use them. It implements the actor model, which I will not explain in detail here, but you can figure out. And it comes with a runtime system that is fault-tolerant and distributed by nature. The system was initially designed to be distributed, not running on a single node. It also has hot code swapping, so there's no need to actually stop the system. So these switches that we saw earlier, they make use of this. Again, please, show of hand. Anyone working with Erlang or Elixir in their day job? Hey, 2, 1, 1.5, 2. So it's still not mainstream. I don't know why. So we saw this switch earlier. The AXD 301 is yet another switch made by Ericsson sometime in the 90s, I believe. And this is the famous one with the 9 nines reliability. They call it reliability. What does that mean? It's a long study that you have to read. There are some assumptions in there, some preconditions to make this work. But essentially, I think you can see, okay, Erlang is being used to build systems that are highly available, that have huge uptime, even if that is a bit of a crazy setup that they did there, and to kind of predict the future, because they didn't run it for 20 years, to be honest. So they calculated after 20 years it would have 0.6 seconds unavailability, and of course that experiment is hard to run. Still, it means somehow this was possible. And how did they do this? So it's interesting. These switches run for years or decades even, and they receive software updates, a lot of them, a lot of software updates. And they receive them at runtime even, without going down. You can never switch off these things. I mean, they've been designed to start with to never be switched off. In fact, Erlang, the first version of Erlang, didn't have a notion of stop. You could start the system, but you couldn't stop it. There was no API for it, seriously. So how did they do this? It's also interesting to note the software that was running on these switches is not tiny, I would say. So more than 1 million lines of code, Erlang code, more than 50,000 functions in 2,000 modules. That's not tiny. So it feels and looks like a big monolith. So somehow the underlying architecture and the development model must support this kind of, development, incremental development, without ever stopping, and with a rather large software. And I put forward it has to do with these attributes. So first of all, it's a functional programming language, and it features immutable data structures. So I think that just leads to less code, fewer bugs that are related to state. It's easier to reason about. It helps. Then there's the actor model, isolation and share nothing architecture. As I said, I can't explain it in detail, but I argue that the isolation that is provided by the actor model means you're guided and kind of forced to write code that is less coupled. You cannot share things, knowledge. You can only send messages. The only mechanism to interact between Erlang processes is to send messages. Message queues is what we use a lot these days, I guess, in microservices. So there's a decoupling there. And in fact, you cannot reach into any sort of deeply nested Java class hierarchy. You just can't. It's not there. So the only mechanism you have is to send messages. And it's asynchronous by nature. So the VM and the programming model, it also supports fault tolerance, resilient systems through supervision trees. So if a process crashes, it will just get restarted. And the VM and the programming model both had in mind from day one distribution. They were never designed to be run on just one node. It was always a distributed system. And there's more. I guess one of the reasons probably was they had a skilled development team. Keep that in mind. So maybe not a huge team, but a skilled one. How can we benefit from this today? So I argue the Elixir Umbrella project is a really, really nice way to make use of this robustness of Erlang, the features that it supports, while giving you a kind of modern and nice and friendly interface. A little bit like Ruby, but please don't think Elixir is Ruby. That's a mistake. So these few lines of code here create an umbrella app. So when I say umbrella app, we see the first line, it creates the umbrella. And the umbrella really is just that. There's no code in it. It's just a kind of, folder structure for the apps that we create later on. So it creates a folder called apps. And in there, we create 3 applications. 2 of them have supervisors. So they build supervision trees. The other one doesn't have a supervisor. Maybe it doesn't need one. And so what we've done here is now we created 3 apps, which when we start them, they will by default all be running within one Erlang VM. So the natural model of deployment for Erlang is you build what they call a release that contains the Erlang VM, and in it there will be a number of applications, all of them communicating only via message passing. So, as I said, by default, all of them will be run in the same Erlang VM, but they don't have to. So you can deploy this in any combination of apps that you like. So you can have a node running A node running B, you can have a node running B and C in any combination that you like. Because you have location transparency. That means if your code works in one node, it will work in distributed mode without any changes to the code. It's just configuration. So if it works on one node, it'll work in a distributed mode. So the programming model also dictates then that developers think in distributed mode from day one. All you have is message passing. Everything is asynchronous, so people think a little bit different when they try to make use of some functionality that's in the other app, and you can't reach into it. Well, supervision trees, the other great feature, which make your software resilient and robust, they are also very good indicators for bounded contexts. So everybody here being microservices focused, obviously we have all read our DDD, so we know what bounded context is. Supervision trees, you can think of also as aggregates, as at least a very good indicator that there's a bounded context. So you can split up your application along these lines later. And that's exactly the idea. Now, you can deploy it as a monolith, Maybe it is not a monolith. I don't know. We can argue. But you can deploy it as a monolith. And so you can save all that hassle that you have to go through when you go for your distributed microservices architecture. So you can focus on business value more, and you can split it up later. You are not facing the situation where your code is so entangled that you can't split it up anymore. Maybe one more detail on these apps. All of them have their own configuration. All of them have their own database by default. That's how you do it. They all look the same, though. They all have the same interface, how to start them, how to stop them. The whole lifecycle management is always identical. Okay, so there's a bit of praise for Elixir Umbrella apps. Of course, you can still get it horribly wrong. You can write really bad Erlang and Elixir code. It's possible. But of course, as we said, we are looking for skilled teams, so that will not happen. Which brings me to the wrap-up. So I don't want to hear these stories that often. The story that I explained in the beginning, that I recalled from the product camp, it's really frightening to see how organizations struggle with this new technology that's supposed to make them faster. And often they are not. So the required capabilities are often not in place. The technology is great. We have all these nice Netflix libs and frameworks and whatnot, but we are maybe lacking the people who can actually run this at scale. Think Amazon, Twitter, SoundCloud. It takes years to build up these systems. So, these resources or these capabilities that are maybe missing in your organization, they are not easy to get by. They are not easy to learn. Well, they are. We can all learn, but it takes time. You have to give the people the time to learn it, or to acquire all that knowledge, which wouldn't be cheap either. And I think that's the main takeaway for me. Any architectural decision, such as monolith versus microservice, will never be as influential as the kinds of developers that you can get together to think in distributed mode, to think in services in bounded contexts. That I think what you should concentrate on most. And yeah, of course, consider Erlang and Elixir. And just to mention I was told very many times by recruiters that I would never find Elixir or Erlang developers. I can definitely tell you that's not the case. I've been hiring Elixir developers since December, and very successfully so. So don't trust the recruiters. Thank you.
Thank you. Questions?
Thank you for your talk. I would like to know which concrete problems did your teams experience while changing to the new architecture style? So what did concretely go wrong?
So the anecdote that's in the beginning of the presentation, that's not my organization. So I did not experience that. So it's just people telling me these stories. I work as a consultant also, so I've been going into organizations and looking at how they cope or struggle with these new architecture styles. So it's not happened to me so far, because I built Monolith.
So what do you mean by struggle?
So, as I said in the beginning, the organization is now facing the fact that they take much more time to get features out of the door. The developers have not got the skills or the knowledge to make use of that system in a way that would really benefit the business. Of course, you can ask, why is that? Maybe did the CTO not do enough to onboard these people, to explain what's happening? Do they just lack skills that you can learn somewhere? But then, of course, you have to learn them, invest the time, give them the time. But as a fact, it takes them longer to roll out features, and they find it very hard to fit any feature into a 2-week sprint. That's what I learned.
So as far as I understand, not the microservices are the problem, but the missing knowledge on how to do it. So maybe your message is let's stick to monoliths, and I would say let's spread the knowledge.
Missing knowledge, missing infrastructure to run these microservices at scale, to make it a simple push button for everyone to deploy and do whatever you have to do, the tracing, the monitoring. I mean, there's so many aspects related to actually running these architectures. That's, I think, I didn't put that much in the slides here, but yeah, of course, there's knowledge. Exactly, how do you run these systems? And you need people to do it. Yeah. I'm not saying that microservices are the reason why you cannot develop proper software anymore. That's, that would be wrong. I'm at the Microservices conference here. So yeah, sure. Thank you.
For me, the difference is more on the how do I cut the microservices? So I think I often see developers that say, oh, let's do microservices, and they take a data center-centric approach, and then you have a feature, and you detect that for this feature you have to do something in this service, in this service, and in this service. So I think the main danger is there. So.
Totally agree with you. So when I say the good skilled team, we need the skills. What I mean is software design. How do you identify and model your bounded contexts? That's the kind of knowledge, especially in microservices. We should all know our DDD. And that takes time to learn, and you have to give that, space and freedom to learn this and talk with people from the domain, these rare people that you never find, and you have to have these conversations. Yes, totally agree with you. That's the main problem also. Yeah. Thank you.
More questions? I guess it's time for lunch. So thanks a lot again.
Thank you.